Hi, good evening. Tonight I'm going to talk about the bridge, SWR bridge, or called coupler, or called reflective bridge. They are the same thing. Uh, the bridge is having 4 ports: A, B, C, D. So between A and B is the main line. So it's bidirectional. So the normally the attenuation is very low. It's like 0.5 dB. Between A and C, this attenuation is bidirectional. It's normally 20 dB attenuation. And D is similar, but normally people cut this out, so you only can see A, B, C here. So we just stick here. So in this particular case, this join in, this is A port, and this is the output port, which is C port, and this is the B port. Let me just stick with the standard bridge, which is A, B, C, what's the unique thing about this bridge? The bridge can do the monitoring. For example, if you have a radio here, and you have some equipment, testing equipment here, and this antenna is here, you send majority of the signal over to this B, and you get a slight little bit of the signal here to monitor the signal quality. So this is doing the monitoring. And this particular one is not good for this function. The reason is that this line, the degree, if I send signals through A, both B and C have equal amount of the signal. So this is 6 dB down, 6 dB down, this one. So this is not fit for this purpose. This is cheap, this kind of expensive ones. And if you open this A port, put it open, just don't put anything here, and send signal from B, the signal goes to A, it will bounce back to here and to here. So you can do some tricks here. I will talk about later. Anyway, let's go back to see how can we use this bridge to do the SWR check. The normal setup is you put antenna at port A here, and radio at B. So the signal is going this way. The radio sends the signal, and the signal goes to the antenna. And these two signals, same signal. We call the outbound signal. I use U, go up. So why I use V? Because that's simplified question. We think this is a sine wave. So V is the peak voltage of this sine wave. Okay, so this is a sine wave, and this volume is this one. The same signal will bounce back by the antenna VB. The VB signal bounce back when you hit this A port. The signal will split. Some go back to the B, And since B is a perfect load, it's 50 ohm load, B will take this in without any bouncing back. Just this signal goes to B, disappeared. Another signal is go to the coupling port, VC, and the VC you put a monitoring device there, and that device is supposed to be 50 ohm, so it will suck in this signal and nothing bounce back. So that's all your signal flow in the antenna and the setup. And now let's talk about the VWR. What's the SWR? Sometimes called the VSWR. SWR is defined as the maximum voltage inside this antenna. Maximum voltage over the minimum voltage. Okay. In this case, let's do a translation. This means this is VU, and there's another bounce back. The phase may be different, amplitude different, but the frequency is same. Let's say frequency is always F. So this is VB. So this is VU plus VB, VU minus VB, and if both sides divide by VU, is 1 plus VB VU, 1 minus VB VU. Okay, we got a formula here. Let's do some discovery. What's the power? The outbound signal power. The outbound signal power, I use U here. Outbound signal power is VU square over 2R. R is load, typically 50 ohm. And inbound signal power, VB, is let's convert this one in the dB mode. So both sides do the 10 dB. So we get a signal in the dB, power in dB. Okay, equals to 20 log VU minus 10 log 2R. Same as this one, P in the dB scale set. I just convert these two signals to here. Nothing, no other change. It's easy to use minus plus to represent the multiply and multiplication and division. So subtract both sides, we can get this formula. So subtract both sides, we can get PdBU, actually B minus PdBU equals 20 log VB VU. See, we try to get this number. So end of the day, we get VB VU equals to 10 over PdB minus dBU over 20. So basically this means that the power difference in dB scale over 20, and we get this one. So now the question is, how can we get the power of the VU and the power of the VB? Okay, let's keep this in mind and first try to get the VU. What happens if my network is set up in this way? Say A, B, and C, but instead of instead of putting antenna here, I open it. What happened? The same signal go here, same signal go here. I'll use this one. Instead of going to the antenna, there's no antenna. This is open, so it will some bounce back, and some goes to here. Okay. Become this I call the reference. Okay. Become VC in reference. Okay. So what's the power in the C port? It's similar to this formula. So dB power in C port in reference mode, which means there's no antenna here, equals same formula here, 20 log VC. What's the VC? Okay, VC minus 10 log 2R. VC and VU has a fixed relationship because VC equals to a particular coefficient, say beta times VU. Okay, so we do this formula again, so we can see that this guy equals to 20 log beta VU, here minus 10 log 2R, and it is equivalent to 20 euro. So it's equivalent to VU 10 log 2R minus plus 20 log beta. Beta is fixed. Beta is fixed and based on the frequency. Same frequency, same beta. Okay. What's this one? This is we calculated earlier. It's the forward power. PdB forward power plus 20 log beta. So the observed, if I open this one, this observed power equal to the outbound power plus a fixed number, okay, fixed by the F. Okay, so we get this one. Now we look at here. What's the PdB in the reflect power? If I add antenna, what I observed from the C port. So if I go to this same formula, I can get PdBC in the non-right reference mode, in the with antenna, equals to same thing here, but instead of VU, now this is VB bounce back. So this is VU become VB, and this is same coefficient beta. So I can get same result, similar result, dB, the bounce back signal, plus 20 log beta. So now we can see clearly the difference between these two numbers. Basically, these two numbers is same as difference between these two numbers, because this is a fixed coefficient and the same frequency for same frequency. So this same formula I can replace by VB VU equals 10 over PdBC with antenna minus the power observed at the C port with antenna, PDB C reference, which means without antenna, over 20. So we add the earlier formula in here. SWR equals to 1 over VB over VU, 1 minus VB over VU. Okay, so this one is with antenna, this one without antenna. Okay, all in the C, at C port. Okay, so this is the formula. Okay, let me write clearly and let's do a measurement. Okay, this is the formula. I summarize this one here. So SWR is this formula, and this one is 10 to minus and over 20. This is the power. This is a two power difference measured both at the C port. One is without antenna, one is with antenna. Okay, let's do a check. Okay, I set this equipment. This is the spectral analyzer. You can see it here. And this is the track generator. So basically, this port send a white noise out, and this port take the measurement. And this white noise is the signal source equals to this port. This is the B port. Okay, and this is the A port. I leave open, and this is the C port. So you can see this wire. So this is what I received from the C port without antenna. So we get this number here. This number. This is different frequency from I believe it's from 500 megahertz all the way to 500 500 kilohertz to 500 megahertz. So we get this number value for each frequency. Now this one, the second one. And in order to see the difference, it's very hard to see difference when the line is curved. But this machine has a nice feature called normalize, bring up to the 0. So you can see this line is artificially brought to the 0 here. So now we can see difference. Whatever difference here is here. So let me hook antenna in. This is a UHF VHF. This is a UHF VHF antenna. Okay, I'm putting antenna in. This is a UHF VHF antenna. So the antenna is now in the port C, port A, and now we can see the. So you can see this is. Oops, sorry. This is the 143 megahertz. It's the VHF, and the other one must be the other is at 454. It's the UHF, and let's do a measurement of the VHF. So this valley, this deep valley, it's 143.69. Let me write it down. Frequency is 143.69 megahertz. And now the difference, we know this is normalized to 0. The difference here, it says 18.74. 18.74 dB. So it's VB over VU equals to, let me do a calculation and show you. Okay, got calculation. So here, So I got 18.74 dB, then VWR, put this 18.74 is minus 18.74 over 20, then you get this VB over VU equals to 0.11, then SWR is 1.26. Let's put on this one here, and this is the spectrum analyzer, and it will show me the number. The frequency is 14369, 143. Let me go to 69. 6. It's about 69. 1.3. I got 1.26. Pretty good. So that's how you get the frequency. So overall, you get this formula, and this is how we get the signal. And on the internet, you can get this table. The table basically, you put this number, the difference number here, and it give you this SWR directly. I just do the hard way. Okay, in the next video, I'm going to show you the different bridge, and show you how to play around with the bridge, how to check the bridge. Okay, good night.